Alright, gang, here we go. Binary ionic compounds. So, this next unit we're talking about is all about nomenclature, which is really just a fancy word for naming. So we're going to take our chemicals, and you're finally going to learn how to name different molecules and compounds that we encounter. So the first one we're going to talk about is binary ionic compounds. So you guys should know that bi means two, and you guys know that ionic compounds are ones that are made with a metal, right, and a non-metal. Okay, so we're going to be talking about molecules or ionic compounds that are made with two things, a metal and a non-metal. Okay, so first we need to make sure we're all on the same page as far as valence electrons. You guys should all be pros of valence electrons now. Okay, remember they're the electrons that are in the atom's outer energy level. Alright, so just to refresh, we need to know how many valence electrons each of these guys have. Okay, sodium is in the first column, it's group 1A, so he has one valence electron. Sodium is in group 5A, or sorry, not sodium, forget, nitrogen is in group 5A, so he has 5, and sulfur is in group 6A, so he has 6 valence electrons. Okay? Alright, so yeah, once again, this is all just review. You can stop and read it on your own. Pretty much, all elements want to get 8 valence electrons, except for hydrogen, right? Except hydrogen. But really, they want to have the same number of electrons as their nearest noble gas to be stable. And in order to do that, they'll become ions, yeah? So, remember that everything in the first two columns here, these guys here, the alkali metals, are going to lose 1 electron to become +1. Remember, the positives are cations. Alright? And then when they form a negative over here, they're the anions. Alright? So here's just a little refresher, like we should all be good at this. Okay? Second column here is the alkaline earth metals, and they lose 2 electrons to become +2. And then we jump over to column 3A over here, and they lose 3 electrons to become +3. And then, remember, this group here is kind of funny, because these guys down here will actually form positives, and these guys up here will form negatives, but for the most part we just say they're 4-. Okay, and then over here, these 5A will gain 3 electrons to go to their noble gas over here. 6A's will gain 2, and the halogens will gain 1. Okay, so they get -3, -2, and -1 charges respectively. Alright, so when you're naming a metal ion, okay, you're just going to use the same element name. Alright, now this is just going to seem real dumb to you for a second. Okay, so this question here, it says, what is the charge and name for the following cations? Well, cesium right here, cesium is in group 2A, right? So its charge is 2+. Okay, and then the name for the cations, well, cations are named by the same element name, so it's cesium, so we're just going to call it cesium ion. I know, it's crazy. Calcium is also in group 2, so it's group 2+, and this will be called a calcium ion. Pretty slick, huh? Now, anions are a little bit different. Anions, you actually have to change the name. You're going to take off whatever's at the end of the element name, and you're going to change it to IDE. Okay, so this guy by itself is phosphorus. Okay, but when it becomes an ion, it becomes phosphide ion. Okay, so everything that is an anion, meaning it's negatively charged, is going to have the IDE ending. Alright, so oxygen, non-metal, it's in group 6, so it becomes 2- charge, and now its name, we're going to take off the end of it, and it's become an oxide anion, or ion, either one. Alright. Sulfur, same thing, in 2-. So, by itself right now, this is just sulfur because it's just an atom. But when it becomes an ion, when it becomes S2- like this, it's going to become sulfide anion. Alright? Okay, so when you write the ion, remember we put it in the top right, and we put the number first and then the charge. So, when ionic compounds get made, remember we talked about how it's a transfer of those electrons, and they're usually made with a metal and a nonmetal. The metals lose their electrons and the nonmetals gain them. Cations are electrically attracted to anions because cations are positive and anions are negative. The opposites attract. Okay? So this is the key part here. A chemical formula of an ionic compound represents the lowest whole number ratio of one ion to another. Okay? So we're going to figure out what we need from both of them in order to make the charge equal 0. Okay, so if you have a sodium, okay, it has a charge of +1, right? 1 plus. If you have a chlorine and its ion is 1 minus, you're going to take this guy here and these two numbers, and you have to figure out what you need to do to either of these so that they add up to 0. Well, 1 plus and 1 minus combined equals 0 already, so this guy is going to be just NaCl. This makes sense if you think about it in terms of our valence electrons. Remember, sodium's valence has 1 electron on the outside. Chlorine has 7, right? 1, 2, 3, 4, 5, 6, 7. So the sodium will give this electron to chlorine in order to form this compound, sodium chloride. It's table salt. Okay. Now if we look at magnesium chloride, okay, so magnesium and chlorine, so what charge does magnesium make? Well, it's in the second column, so it's going to be a charge of 2 plus. Chlorine is a halogen, is going to be minus. Now if you notice, this is now a 2 plus and this is a 1 minus, so this means we need 2 of these chlorines in order to balance out the charge of the magnesium. Okay, so magnesium is +2, so we need 2 chlorines. So it would be magnesium Cl and then chloride Cl2. Alright? So we can also think about it this way too. Same way, if we take magnesium, it has 2 valence electrons, right? 1, 2. Chlorine here still has 7. 1, 2, 3, 4, 5, 6, 7. Well, magnesium can give up one of them to go here, but it's still got this other valence electron that needs somewhere to go, because remember, magnesium has to make a 2 plus. He's not going to stop at 1 plus. He wants to be like the noble gas. So then it takes a second chlorine that has 7, 6, 7, to take this last valence electron. Okay, so once again, magnesium is a 2 plus, chlorine is a 1 minus, so it takes 2 chlorines in order to balance out the magnesium. So it becomes MgCl2. Now, there's a cheating way. Well, it's not really cheating. I mean, it works, but there's some conundrums and stuff. It's called the crisscross method. All right, and I'll show you both ways to do it. My way, where you add up to 0, or the crisscross method. All right. So when you're watching the video, I'd flip back to this or refer to your notes for the steps, and we're just going to do both methods together on these couple of things. So when you're writing formulas, the first step always, either way, is you're going to identify what charge these things are going to have. Well, potassium has a charge of +1, so we'll just write a plus above it, and nitrogen has a charge of 3 minus because it's in the 5A column, so it needs to gain 5 electrons. Alright, now, how many potassiums do we need to match the nitrogens? Well, there's 3 minus nitrogens, okay? So it has a charge of -3, and our potassiums only have a charge of +1. We need to get them to add up to 0. So that means we need 3 potassiums for every 1 nitrogen. Okay, K3N. Now, there's another way you can do it, and that's the crisscross method that's there before. All you have to do with crisscross method is you take the charge here, and you're just going to put it down at the bottom for the nitrogen, and you're going to take this guy, put it down for the bottom for the potassium. Okay, so potassium, and then you're going to get rid of the symbols. Okay, so this becomes K3N1. Okay, but our second rule in the crisscross method is if we have a 1, it's just going to be understood, so we're just going to assume that it's 1, so it just becomes K3n. Alright, so notice how you end up with the same answer either way. This way you're just adding up charges to equal 0. This way you're crisscrossing the charges. So let's try another one. Lithium is in the second column. Nope, first column, I lied. So it has a charge of +1. Oxygen is in the 6A group, so it has a charge of 2-. Now if you just, we need those charges to add up to 0, so we know that we need 2 lithiums for every 1 oxygen, because lithium has a +1 charge, oxygen has a 2- charge. So really this guy will just become Li2O. Alright, or you can do crisscross method, where you'll bring this one down here, this one over here, this becomes Li2O1, and we get rid of that 1 because it's understood, so it becomes Li2O. Now, magnesium sulfur, alright, so magnesium's in the second column, so it has a charge of 2+. Sulfur is in group 6A, so it has a charge of 2-. Alright, now here's where the adding up is superior, in my opinion. Here we know that this is 2+ and this is 2-, so we just need one of each of them in order to equal 0, right? A 2+ and a 2- equals 0. So this guy just becomes MgS. No problem. No muss, no fuss. Now, if you do crisscross method, if you bring the 2+ down here and the 2- down here, then you get Mg2S2. And then, now notice how both of these numbers can be divided by 2. You always want them to be the smallest whole number ratio. Well, this isn't the smallest whole number ratio, because you can divide them both by 2. So we'll divide them both by 2, and we get MgS. Notice how we get the same things. Okay. Now, we're going to go backwards. Okay. We're going to, before we were given the 2 elements, and we're going to try to figure out how they combine. Now we're given the ionic formula, and we need to figure out what its name is. So all you have to do is name the cation. So you know that this was just magnesium 2+, and then you're going to name the anion, and this was bromine 1-. Right? So the name of this guy is simply magnesium. Remember, because cations are just named with just the cation, which is just the element name like normal, and anions are named with the name of the element, but we change it to -ide. So this, instead of bromine, is become bromide. Magnesium bromide. Okay, and then now we have aluminum. Okay, so Al is just aluminum, because it's the cation, right? Aluminum is in the 3A column, so it forms a cation. This is aluminum 3+, and this is our anion, Cl-, so it becomes aluminum chloride. Alright, and then last one, the cation is barium, right? Ba2+. Notice how the cation is almost always first. This is the standard way to write it. You write the cation first. And this is the anion oxide. And so this is simply barium oxide. Alright, now finally we're going to take the name and we have to write the formula. Alright, so we're going to look at our 2 ions. So the magnesium is our cation. So we know that magnesium forms a 2+ ion. And we know chloride is really chlorine, and it's a 1-. And now from here, we're just doing exactly what we did 2 slides ago. You can either do crisscross, or you can add them up. Either way, this becomes MgCl2. Okay. Now we have strontium sulfide. Strontium is Sr2+. Sulfide came from sulfur, which is in 6A, so that means it's 2-. Notice how a 2+, 2-, they add up 1 for 1, So this just is SRS. And then finally, sodium is Na. It's in group 1A, so it forms a charge of +1. And then phosphide comes from phosphorus, which is P. And phosphorus is 3 minus, right? Oh my goodness. I'd hate to steer you wrong here. Yeah, 3 minus, thank goodness. Alright. And so we need 3 sodiums to balance out our phosphorus. So this becomes Na3P. And that's it. Do your practice and come to me when you're ready for your checkpoint.